Alright, so just a reminder that we are on day 3 of our notes, okay? And so we are starting on number 19. Okay, so over the last several weeks, as we've been covering Module 3, we've factored in this module, so you know that if A is not 1, that we simply went straight to parentheses, right? And then we talked about if A is anything other than 1, we use what method? The bottom up method, right? Okay, and then we've talked about how you always want to look for a GCF first. We've talked about all of those different things. Last week, or the week before spring break, we also looked at solving these quadratics, okay? So remember, we said that if you solve, then you have to factor first, and then what do you do after you factor? You set each piece equal to what? What we do up here on number 18? Set each piece equal to 0 and then solve, right? Okay, so if they've asked you to solve, then first you want to get everything on the same side of the equal sign. You want to factor, and then you want to set each of those pieces equal to 0, okay? And so that's the additional step when they ask you to solve. So look on number 19. This one's going to be a little lengthy, okay? Because we are going to have to multiply out first and then get everything on the same side of the equal sign. All right, so I'm going to come over here so that I have some more room, okay? So y plus 2 squared, that means that we need to full that. Right, so y plus 2 squared means that we need to full that. So we have y plus 2 times y plus 2 equals 2y squared minus 4y plus 16. Alright, so we're going to full, and that gives us y squared plus 2y plus 2y plus 4. Is everybody with me on that? All I did was full the left. First, outer, inner, last. And then I'm going to bring down everything on the right. Alright, now what do we do at this point? I know it's been a whole week since spring break, but what do we do at this point? Get everything on one side and combine like terms, absolutely. So we know we're going to go ahead and combine those, so that's going to give us y squared plus 4y plus 4. Now remember, we talked about this last time, but we really want this y squared to be a positive. Okay, so it doesn't matter if you take those terms to the left or to the right, but we want our squared term to be positive. So instead of moving all this junk on the right to the left, then I'm going to move this junk on the left to the right, so that I'll have 2y squared minus y squared, and that will give me a positive y squared instead of a negative. Does that make sense? Okay, so I'm going to move everything on the left to the right, and I'm going to group it together as I move it from the left to the right. Okay, so again, that'll all be equal to 0, and I'm going to have 2y squared minus y squared minus 4y plus 16 minus 4. So I brought my 2y squared down. Okay, I moved this y squared over, making it negative. Bring my negative 4y down, bring 4y over, making it negative, bring 16 down, bring 4 over, and making it negative. Okay, so now continue to combine those like terms. So 2y squared minus y squared is y squared, right? What's negative 4y minus 4y? negative 8y. And 16 minus 4 is positive 12. Alright, so I know this problem is a little lengthy, okay? But now what do we need to do? We talked about this. What do we need to do? Now we need to factor it, right? So then we can set both pieces equal to 0. So my A is understood to be 1, so that means I can go straight to parentheses. And I need two things that multiply to be 12 and add to be 8, okay? And so I'm hearing 2 and 6. And what are those signs going to be? This is a positive, so we know that both of our signs are going to be the same, right? And this is a minus, so we know they're both going to be negative. Okay, so this factors into y minus 2 times y minus 6. Okay, now what do we need to do? Because the directions actually tell us to solve, right? So now what do we need to do? We don't need a full, but we need to set each piece equal to 0 and solve for y, okay? So remember, that's your new part on these, is after you factor, then you set each piece equal to 0 to get those two answers. So we have y minus 2 equals 0 and y minus 6 equals 0. So then what are those two answers going to be? Y equals 2 and y equals 6. Very good. Now in ALEKS, before the break, we talked about the fact that when you enter this in ALEKS, they're going to have y equals. You're going to enter both answers, and what do they tell you to do? To put a comma in between the two answers. So you'll just list 2, 6. Okay? 2, 6. Alright, so I know that was lengthy, but again, the process is still the same. So what questions do we have on number 19? Questions on number 19. Alright, let's look at number 20. Now, when we look at number 20, I'm going to give you several words that I want you to, that I'm going to underline or circle, because when you see these on ALEKS, I want you to recognize those words, and that's going to tell you what to do on these problems, okay? So on number 20, it says find all excluded values. Circle that word, okay? For the expression, and that is find all values of u for which the expression is undefined, okay? So your two key words here are excluded and undefined. Now, what makes a fraction undefined? When is something undefined? When there is a 0, or y'all wait, a 0 in the, y'all, I know y'all know this, you just are
Still on the spring break.
still on spring break mode. Alright, so we know that a fraction is undefined if 0 is in the denominator, okay, in the bottom. So it says find all excluded values for the expression, that is, find all values of u for which the expression is undefined, okay? So you know that this expression is undefined when the denominator equals 0. Okay? So the only thing we're worried about in this fraction, or in this rational expression, is the denominator. Okay? So when you see those directions, and you see excluded and you see undefined, the only thing you're worried about is the denominator. Okay? So we're going to set the denominator equal to 0, and then we're going to do the exact same thing we've been doing. We're going to factor and then solve. Okay? Same thing we've been doing. Factor and then solve, except for the only difference is you're only concerned about the denominator because it's asking you find all excluded values. Okay? Does anybody remember us factoring something like this before the break? u squared minus 49 is special. Do you remember why it's special or what we call this? It is the, what do we call it? What are both terms? They're both perfect squares, right? And what's happening in the middle? We are subtracting. So what do we call that? The difference of squares. Woo, y'all are asleep on me today. All right, so that is the difference of squares, right? Do you remember how we factor that? Both parentheses will have the exact same numbers and variables, but what will be different? Since it is the difference of squares, what's different? Our signs are different. One will be a plus and one will be a minus. So, we're going to have two sets of parentheses. It's going to be u plus 7, u minus 7, or u minus 7, u plus 7. Doesn't matter the order, right? So then what are my two answers going to be? We're going to set u plus 7 equal to 0, u minus 7 equal to 0, and my two answers are going to be u equals negative 7 and u equals positive 7, right? Okay? You're going to see some like this in ALEKS if you haven't already, okay, and possibly one on your test, and make sure you know that when it says excluded or undefined, we're focusing on the denominator, okay? All right, what questions do we have about number 20? Questions about number 20? All right, let's look at 21. Let's look at 20. Go ahead.
So we're not going to touch the top part?
No, because the only thing we're concerned about is the denominator, because it says, where is this expression undefined? So the top doesn't have anything to do with the expression being undefined. So that's why I said those key words on this one are so important. Okay? Other questions on number 20? Okay? Alright, let's look at 21. Alright, starting on number 21 through the end of our notes, they're going to ask us to start simplifying, multiplying, dividing. Okay? And so what we're going to do is we're still going to factor anything that can be factored. Okay? We're going to factor anything that can be factored. Alright, so that means, and then after you factor anything that can be factored, then you're going to cancel things out. Okay? So it doesn't matter as long as one's on the top and one's on the bottom. They can be across from each other, or they can be immediately on top and bottom, okay? But if one's on the top and one's on the bottom and they're exactly the same, then they can cancel, all right? So let's look at 21, all right? The bottom cannot be factored, okay? So we're just going to leave that as x plus 2. The bottom cannot be factored, so we're just going to leave that as x plus 2. Can the top be factored? Can the top be factored? Yes, okay. And A is understood to be what? What's A understood to be on this one, on the top? What's understood to be right here? A 1, right? So if there's an understood 1 there, we can go straight to parentheses. Very good. Alright, and so we're going to have x and x. We need two things that multiply to be 14 and add to be 9. Okay, 2 and 7. And what are my signs going to be? This plus tells me that my signs are going to be the same. And this tells me that they're both going to be plus. So it's going to be plus 2 plus 7. Alright, and then what do you notice? What happens here? We have an x plus 2 on the top, and we also have an x plus 2 on the bottom, and so they cancel. And so the only thing we're left with on number 21 is x plus 7. So that is your final answer, x plus 7. That is your final answer. questions on 21. Questions on 21. Okay, let's look at 22. Okay, on 22, there's not anything that can be factored, okay, but they are asking us to multiply, okay? So you are going to have to remember your exponent rules, and that is that when you multiply and your bases are the same, then we add those exponents, right? And when we divide and those bases are the same, then we subtract those exponents, okay? So the easiest thing to do, in my opinion, is to go ahead and multiply everything straight across on the top and everything straight across on the bottom, and then cancel, okay? So on the top, when I multiply everything on the top, then what am I going to get? 15b cubed c what? C squared. Very good. Is everybody with me on that? Then on the bottom, what am I going to get? What's 9 times 2? 18 b squared c cubed, right? Now we're just going to simplify, okay? Keeping in mind that when we divide, we do what with those exponents? When we divide, we do what? Subtract our exponents, okay? We subtract those exponents. And your coefficients, that 15 and 18, you're just going to reduce like you would a regular fraction, okay? Because that's what it is, all right? So 15 over 18. What will go into both 15 and 18? 3. Okay? So we're dividing both of those by 3. How many times will 3 go into 15? 5 times. How many times will 3 go into 18? 6. Okay? Now look at your B's. I have 3 B's on top and 2 B's on the bottom. So how many B's am I going to have left? 1, and where's it going to land? Top or bottom?
Top.
It's going to land in the top. Okay? Now, I don't know if y'all remember this or not, but I always tell my students that when you're subtracting, okay, so that you don't have to deal with negative exponents, just look at which one's bigger. So say 3 minus 2 is 1. I know I'm going to have 1 left over. 3 is bigger than 2. 3's in the top. I know it's going to land in the top. Okay? So here, I still have 3 and 2. So I'm going to say 3 minus 2 is 1. I know I'm going to have 1 C left over. But 3 is bigger than 2. And this time 3's in the bottom. So my C is going to land in the bottom. Very good. Okay? So then my final answer is 5B over 6C. 5B over 6C. All right, questions on 22. All right, let's flip it over. 23. Alright, so again, we're still doing the same thing, okay? So anything that can be factored, factor, and then we're going to cancel out, okay? So, x plus 1, that will not factor anymore, so we're just going to leave that as x plus 1, right? Now, what about on the bottom right here? X squared minus 3x plus 2, will that factor? Yes, so we can go straight to parentheses, right? So we're going to get x and x. We're looking for two things that multiply to be a positive 2 and add to be a negative 3. What's that going to be? 1 and 2. And what are my signs going to be? Both are going to be negative. Both are going to be negative. Okay, what about over here on the top? I have x squared minus 4x plus 3. Will that factor? Yes. So now I'm looking for two things that multiply to be 3 and add to be negative 4. 1 and 3. And my signs are going to be what? Both. Well, right here, this plus tells me they're going to be the same. This tells me they're both going to be negative, right? Because they have to multiply to be a positive 3 and add to be a negative 4. All right, what about on the bottom? 3x plus 3. Can that be factored? Be careful, can it? What do you always check for first? A GCF. A GCF. All right, so does 3x plus 3 have a GCF? Woo, y'all are asleep. 3x plus 3. Does that have a GCF? Which is 3, right? Okay, so I can factor out a 3, and then what am I left with on the inside? X plus 1. Okay, so now that we've factored everything on top and bottom, okay, now what can we do? We can cancel things out, right? So this x plus 1 and this x plus 1 cancel. What else cancels?
X minus 1.
The x minus 1's cancel. So what are we left with? On top we're left with x minus 3. And on the bottom we're left with what? 3 times x minus 2. And so there's your final answer. X minus 3 times, x minus 3 over 3 times x minus 2. All right, questions on 23. Questions on 23. All right, we're going to skip 24, okay, because it's very, very similar to the one that we worked a while ago. And plus, it's dividing, and 25 and 26, we're both doing division, okay? So we're just going to skip 24. All right, and so let's look at 25. We're doing the same thing on 25, except for we're dividing. So think back to dividing fractions. What is the only difference between multiplying and dividing fractions? What do you do when you're dividing fractions?
Flip.
Right. You keep, change, flip, right? You remember that phrase? Keep, change, flip. And what do I mean by that? Keep the first fraction exactly the same. Change, right?
Second one, 4x plus 8 is going to be the top, and the x minus 2 is going to be the bottom, and it's going to be multiplied.
Right. So you keep your first fraction the same, change your division to multiplication, and then flip that second fraction, okay? So anytime I see division, I always do that first, okay? So that I don't forget to keep, change, flip. So this is going to be x minus 1 over x squared plus 5x plus 6 times 4x plus 8 over x minus 2. Okay, so I'm going to go ahead and keep, change, flip first so I don't forget. Now this is going to work exactly like number 23, right? Not going to be any different. So after you keep, change, flip, you factor everything that can be factored and then cancel anything that can be canceled, and you're done. Okay? So x minus 1, that cannot be factored anymore, so we're going to leave it. What about x squared plus 5x plus 6? That can be factored. Alright, and we're looking for two things that multiply to be 6 and add to be 5. Alright, think about it. 1 and 6 do multiply to be 6, but can I add 1 and 6 to get 5? Because both of these signs need to be positive. So instead of 1 and 6, I need to use what? 2 and 3. Very good. Okay, and they will both be plus. Because I need to multiply to be a positive 6 and add to be a positive 5. Okay? Alright, what about on the top? 4x plus 8. Can that be factored? What do you notice? It has a what? A GCF of 4. So we're going to factor out 4. And what does that leave you with? X plus 2. And then on the bottom we still have x minus 2. Alright, so what cancels? The x plus 2's. Does anything else cancel? Nothing else is going to cancel, right? So on the top you're going to be left with 4 times x minus 1 over x plus 3 x minus 2. So on the top you're going to be left with 4 times x minus 1. And on the bottom, you're going to be left with x plus 3 times x minus 2. And that is your final answer. Okay? That's your final answer. Alright, questions on 25. Questions on 25. Alright, final one. Let's look at number 26. Okay? Alright, now I know this is written differently, but we're still doing the same thing, right? Because what is this bar right here in the middle? Division. Okay, so I'm still doing keep, change, flip, right? So we're going to keep 7t to the 5th u squared over 9s cubed. Change my division to multiplication, and then what am I going to do with this fraction on the bottom? Flip it. So I'm going to have 3rs squared over 14t squared u. Okay, so my first step is still to keep, change, flip. Alright, now I need to simplify, okay? Now, you can multiply straight across like we did earlier, okay? On, I believe that was number 22. Or you can also cross simplify, okay? So I'm going to show you how to do that because I think it'll actually be easier. But if you want to multiply straight across on the top, straight across on the bottom, and work it just like we did 22, you can do that as well. Okay? Alright, so notice on your numbers we have 7 and 14. What will go into both 7 and 14? 7, right? So 7 will go into 7 one time. How many times will 7 go into 14? 2 times. Okay? What about your 3 and your 9? What will go into both of those?
3.
So 3 will go into 3 once, and it'll go into 9 3 times, right? So then your numbers are 1 times 1, which is just 1. And on the bottom, what do you have? 3 times 2, which is 6. Right? Alright, so now look at your variables. It doesn't matter that my t to the 5th, that they're across from each other, okay? If one's on the top and one's on the bottom, you're still doing the same thing. So I have t to the 5th in the top, t squared in the bottom. So I'm going to subtract, and how many t's are going to be left? I have t to the 5th and t squared.
T3.
T to the 3rd, and where are they going to land? The top or the bottom?
Top.
The top. So I'm going to have t cubed in the top. Alright, what about your u's? I have u squared. I'm going to mark these out so you'll know you've already done those, okay? U squared over u. How many u's are going to be left? 1, and where's it going to land? The top. Very good. Mark them out so you know you've already done them. Alright, what about r? Do I have any r's in the bottom? No. So what am I going to do with that r? I'm just going to bring it down. And I have s cubed in the bottom, s squared in the top. How many s's are going to be left? 1, and it's going to be in the bottom. Okay? Alright, do I have to write this 1 right here?
No.
It's understood, right? Okay? And you can write these as t cubed, u, r. Typically, we write our letters in alphabetical order, but it's still fine if you don't, okay? So we don't have to write this 1, but this would be r t cubed u all over 6s, and that would be your final answer, okay? But again, if you left your r at the end, that would not be wrong, okay? But you do not need to include the 1, or it's going to tell you it's not simplified completely, okay? Alright, so what questions do we have on 26, sorry. Alright. Okay, that is all of your Module 3 notes, okay? So we have completed all of those Module 3 notes, so don't forget that your goal is to get that test completed by next week, okay? And now we're going to spend the rest of the time working in ALEKS on whatever you need to work on, okay?